Hello and welcome to another episode of Microchips. In this episode we'll be opening some post and looking at another Harvard 410T CB radio that I bought off eBay as parts not working. And let's see if this one actually got a fault and see whether we can actually repair it. Anyway, on to the first packet. Something from China. And it looks like we've got some PCBs, and they look like the 3-cell battery management PCBs. Let's take a closer look at these. Yeah, all looks good. I can see the standard 6-pin lithium charging ICs on them and some nice MOSFETs or whatever they are, and this takes 3.7 volts lithium ion cells, probably 18650s, and does a balanced battery charging over current, over voltage, all that lot. And here's the eBay listing with how to wire it up, and I specifically wanted a 12 volt one. And scroll down, have a look at the listing. Yeah, 20 amp. We'll need that circuit diagram for later on. All looks good, so maybe another video whilst we test those out. Here's a close-up shot I took with the camera. Just have a look at it. All looks nice. Six pin ICs on there. Maybe for the battery battery management and the over voltage, over current protection. Some 0.005 ohm resistors. All looks good. Anyway, on to the next packet, see what we've got. And this looks like we have some 4049 ICs. Some CD 4049s, which I believe should be hex inverters for, yes, another upcoming project. Let's take a closer look at these. Yep, CD 4049s. I'll have to be careful with ESD discharge on these. Oh, should be good. Everything looks good there. Let's have a look at the eBay listing. £2.75 for 5. Yeah, it's fine. I hope they're genuine. They didn't come from China, so should be okay. And the next packet. And we have an antenna. A rubber duck type of antenna, but with a BNC connection on the bottom. Yeah, all looks good. Looks fairly well made. Looks like there's a nice loading coil in the centre. BNC on the bottom. Let's take a look at the eBay listing for this one. £6.32 each, and this one did come from China. Took quite a while to get here, but that's one of the things. So again, we'll have to test this. It's for 27 megahertz, so maybe there's a conversion of one of my handhelds in the process. I'll have to see how it performs. And on to the next packet. And what do we have? IC sockets. Funnily enough, the same size as the CD 4049s, and a 20-pin socket as well. Won't go into both listings, but there they were. They were like £1.49 for the 4-pack. You can see they're available in all different sizes. I got 16 pin and 20 pin ones, so all good. On to the next packet. A little bit harder to open this one, so we'll just rip it and have done with it. Trying not to show any information on the thing, and what looks like we have some ICs, and we have some LC7132 phase lock loop ICs. I wonder what those are going to be used for. What is concerning is that they don't have the Sanyo label on them, like the 7137 normally has a Sanyo picture on it. But it's UK company. Okay, a little bit expensive, but you know, these ICs are possibly getting on 40 years old. Well, since the first ones, but £4.75 each. Bought two of them because why not? And they're from the UK again. And this one had already opened, but kept it sealed. There's another frequency counter module that I saw whilst I was looking on eBay. Now, I'd already modified the other frequency counter module that I'd got, popped it in a nice case, which you'll be seeing later on in this video. But this one's supposed to do 1 to 500 megahertz. Let's see how accurate it's going to be. Construction looks good. SMA connector on the top, or on the bottom, whichever way you look at it. On the top, powered by a 9-volt battery. So let's fire it up and see what happens. Or let's have a look at the eBay listing, and then we'll fire it up. But £9.70 from China. But yeah, 1 to 500 megahertz. Supposedly. High accuracy RF frequency counter. So I popped a small SMA antenna onto it. Fire it up. Okay, let's get my Baofeng handheld. Let's do a transmission and see what happens. So we have the Baofeng set to 144 megahertz, and yes, I am a licensed radio amateur, and 144.0204, so running a little bit high. Let's have a look at the top end, or the middle end, 145. Quick transmission on there, 145.206, so that's running a bit high. Let's have a look at the bottom end of the 70 SEMS band. Okay, doesn't seem to be reading straight away. Not sure why that is. Ah, there we go. It's just running. It's just a bit close. And that is quite high, 430.06. Let's go on to 446. Take it slightly away, 446.06. So it is slightly high. There is an adjustment on the back. Let's compare it against my other frequency counter. Now you can't see them both due to the backlight on the other one, but you can see that you can't see the small one, but the big frequency counter did show 446. Let's go to 144. And there you go, that's practically bang on 144. On the other frequency counter module, you can see the strobing of the other one, but you see 446 is high, and the other one does actually say 446.000. So it does need a little bit of adjustment, but maybe that's something for the future. And on to the star of the show. Now I know what this is going to be because I've had it for a little while, sat on my desk. Was concerned about the packaging just being in bubble wrap and one of these packing envelopes, and these packing envelopes seem to be very, very strong. But nice layer of bubble wrap. Okay, let's cut this. Try not to go into the actual radio itself, and it looks like a Harvard radio, which is good. We'll say they have done the best to protect it. Oh, looks a little bit dirty, but what do you expect for a 40-year-old radio? There it is, the antenna's broke as per the listing, so that's fine. Funnily enough, we've just bought another antenna. Let's have a look in the battery compartment. Looks a bit battered on the back. And we have lots of lovely corrosion inside. Let's have a look at the listing. So I paid £13.76 for this, plus £5 postage and packing. So yeah, okay. And we seem to have some wires coming out of the charge port socket and a small crack on the side, but never mind. And there is no screw in the bottom of it, and the back just comes off. A little bit of corrosion got onto the board around where the PTT switch is. There's a screw up the top there. A closer look. Everything looks okay. That variable resistor pot in the right hand side looks like it's been turned fully. I'll have to have a look on the schematic, find out what that does. Let's take the screws out and have a look at the bottom of the board. Let's have a look at that, why that wire is coming out of the charge port. And at first I didn't see the screw next to the PTT because it's covered in so much corrosion. I just thought it was not a screw, but yes, it's a screw. Compared to the other Harvard radios that I bought off eBay, this one's definitely had a harder life. Let's take away the top section, the top plastic work, make it easier. And let's have a look underneath the board. Oh dear. Whatever that is. That's not looking too healthy, to be honest. Not sure what has happened there or why. I'm sure it can be removed, because I don't think I'll ever going to be charging iCAD batteries in it. So I could probably just link it out of the circuit. Let's have a look at the diagram again, find out what that's all about. Everything looks okay. 81 on the chip in the top right. None of the cores are broken. That VR looks like it's been cranked all the way over, so we're going to have to find out what that is. None of the pots seem to be snapped, but this thing floating in the bottom concerns me. So let's power it up, and we have a channel display. That's good. We have hiss, which is also good. Right, let's put it on frequency counter, see if it transmits. And no movement from the S meter, nothing on the frequency counter, and no movement on my current meter on the current power supply, because the last one I did went up to at least an amp on high power. This is not moving at all. So we have a problem. So let's put it against my other radio and see whether we can actually hear anything. And yes, we can hear something coming out of the Harvard, which is good. So the PLL isn't dead, but nothing on the S meter. So that's two problems we've got. I'm still concerned about this bodge. Trying to keep it away from the circuit board whilst I'm doing my testing. And still no movement on the S meter. Let's see if we can hear anything on the realistic coming from the Harvard. And yes, we can hear something. It seems to be very weak, and we can hear the tone. But it's very, very, very weak. Maybe there's some corrosion in the high-low power switch, don't know, I'll have to check that out. But it's not even drawing 1/4 of an amp for low power, it's drawing absolutely nothing on transmit. So the PLL seems to be good. I'm suspecting maybe that sometime in its life that bodge of wires has touched something in the power output stage and seen something off. But that's going to make a good video. And there's a problem with the S meter. The wire has been corroded and this fell off, so that's fine. We can look at another radio to find out where that lives. And there we have it. That's as far as we're going to go today with this video. So stay tuned for part 2 when we actually try and repair this poor Harvard and see whether we can actually bring it back to life properly and make it look half decent and give it a good clean. So as always, thank you very much for watching, and see you in the next episode.